Okay, let's get started. Is it fine? Let me see. Numpy. Okay. Hey everyone. So in today's class, we are going to discuss numpys. So what is numpy? Numpy is a standard package in Python. We discussed in the previous class that Python provides a lot of standard packages and numpy is one of them. Numpy is basically a general purpose array processing package. It provides high performance multi-dimensional array objects, and we are going to discuss Numpy in details. So Numpy is basically for arrays. It's a package for arrays in Python. Numpy is a linear algebra library for Python. The reason it is so important for data science with Python is that almost all of the libraries rely on Numpy as of their main building blocks. And Numpy is fast as well. Array in Numpys is a table of elements, and all of the elements have to be of same type. So let's get started with Numpys. Let's write some code and then understand. So first we will have to import Numpys. So as I said, Numpys is basically a package for arrays, and first to create a Numpys arrays, we'll first have to import Numpys. And we do it by import numpy as np. You can write import numpy as anything. You can import it as nump or np, anything. Generally, it's imported as np. That's how generally people use it. That's why I'm writing it as np. So what we are doing here is we are importing the numpy package by the variable name np. And let's run it. How do we run? We do shift plus enter. Okay. Now, let it run for some time. See, it's initializing. So basically now it's connected and now it will run. Yes. So numpy arrays are the main way in which we will use numpy throughout this course. Numpy arrays come in two flavors. So numpy arrays come in two flavors. One is called vectors, which are basically 1D arrays, and the second one is matrices, which are 2D arrays. And as I already told, arrays in numpys are table of elements of all of the same type. So there are two types of arrays, 1D arrays and 2D arrays. 1D arrays are called vectors and 2D arrays are called matrices. Yes. Okay. Now let's get started. First, we are going to create a 1D array. So how do we create it? So from np, we call array. If you do control space, you're going to get the different options. You're going to get different options and we have to see the first option, which is array. So np.array, and here you can provide a list of elements that you want in your array to be. So how do you provide a list? By the square braces. So let me write 1 4 7 9. So let's see. So now what you get is basically an array which has been generated and there are 4 elements, and this is basically an array, a 1D array. You can also call it as a vector, and it's basically an array of rank 1. Rank 1 means it's a 1D array. There's just one record, you can say it's one dimensional. So this is a array, it's a vector, it's a array of rank 1. So rank 1 array. This is how I write the comments. Now let's create a rank 2 array. So here what I have to do, again I'll call np.array, and here I have to provide the 2D array. The 2D array would be a 2D list. So basically what we have, let me explain it with the sketch. So 1D array basically means that it's one dimensional. A 2D array means that there are 2 dimensions. So let's say this is the first list and this is the second list. So basically what we want our 2D array to have this entire thing. So the first array, the first 1D array in it would be 1, 2, 3, and the second 1D array in it would be 4, 6, 8. So basically a two-dimensional array will have multiple 1D arrays. Okay, so what do is we first provide this 1, 2, 3, and then we provide this 4, 6, 8. So first list that we provide is, let's say, 1, 2, 3, and the next one that we provide is 4, 6, 8. And let's see. So what we have got is basically an array of rank 2. Rank 2 means it's a two-dimensional array. Okay. Now we can directly put the list here, or what we could do is we could first create a list and then in np.array just provide that list name. Let's see how do we do it. So we can create an array by directly converting a list or list of lists. So let me say li, it's the list that I'm creating, and it is 1, 2, 3. Okay. Now what do? In np.array, I just provide this li. So instead of providing the list like this here, I can just provide the variable name which stores this list. So I get np.array li as this list. If I want, I can use the same example and maybe call this 1479 as list. So now what you see is we get the array, a 1D array. Similarly, you can do this for 2D array. We can call matrix is equals to, and here we provide a list of lists. So we have 1, 2, 3, then we have 4, 6, 7, then let's say we have 7, 8, 9. So this is basically my matrix. How would it look like? It would be a list of lists, which is 1, 2, 3, then we have 4, 6, 7, and then 7, 8, 9. So basically what would happen is, in the 2D array, this would be the first 1D array, this is the second 1D array, and this is the third 1D array. If it's a list of lists, then this is the first list, this is the second list, and this is the third list. So now what I can do is, in np.array, I can put this matrix. So basically this matrix, that is the list of lists, would be converted into a 2D array. That is the array of rank 2. Now, this is the basics of numpys. Now, what do is, now we have, let's discuss some built-in methods. Built-in methods that are provided by numpys. So there are a lot of built-in ways to generate arrays. So let's first see those ways in which we can generate arrays. The first is called arrange. Arrange, let me write it. So this is the function that we are going to use. So arrange can be called with varying number of positional arguments. So we can just say arrange, it's something similar to what we did in range. So how do we call this arrange? So we can call it as arrange, and we can just give the stop parameter. So what will this do? It is going to generate an array with all the values from 0 to stop -1. So if, let's say, I have arrange and I say 10, so basically an array would be generated of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically it's something very similar to the range. So what will happen is an array would be generated for all the integers from 0 to 10 minus 1, which is 9. Now if we call arrange with two parameters, that is start and stop. Stop is a compulsory parameter, start is an optional one. So let's say, for example, arrange 2 to 10. Then what would happen is we'll get an array with numbers 2, 3, 4, 5, 6, 7, 8, and 9. So essentially what happens is that whatever element is here, it's basically the starting element of the array, and the ending element would be stop -1. Now what we could do is we could have another variation, which is start, stop, and then we have step also. So for example, arrange 2 10, and 3. So basically, here we are going to have the array starting from 2 and would end at 10 minus 1 or something less than 10. And step is going to be the spacing between each of the elements in the array. So the first element would be 2. The next element would be 2 plus 3, which is 5. The next element would be 5 plus 3, which is 8. Now the next element could be 8 plus 3, but 11 is greater than 10, so our array would just be 258. Right? Does that make sense? Okay, let's try to see this arrange with a few examples. I already told you the examples here for helping you understand it, but now let's see it with actual examples. Now, how do we call the arrange function? We just say np dot and call the range function. I did a control space and I'm just trying to write arrange. And I want to see, yes, I get the suggestion. So now if here I just provide 10. So basically what would happen is an array is created from 0. The first element is 0, then it goes to 1 and so on till 9. Why 9? Because the end element is not included. So it starts from 0 by default and it ends at stop minus 1. Now if I do np.range and I have 2 from 2 to 10, then 2 would be included, 3 would be included and so on till 9. Then if I do from basically start from 2, end at 9 and take a step of 3. End at 9 or less than 9. That is end at 10, end at something less than 10. So we start off with 2, then we go to 5, then we go to 8. But 11 is greater than 10, so it won't be included. So here we are taking steps of 3. That is the difference between two values in the array is 3. Okay, so this is one way to build arrays, that is generate arrays, and this is commonly used. Let's move on to another way. So if we want to generate arrays of zeros or ones, then we can use zeros and ones functions. So if you want to have if you want to have an array of 3 zeros, that is, for example, if you want the array like 0, 0, 0, then what you do is you call zeros function. Let's see, yes, zeros, and then just say that I want an array with 3 elements, and you get an array with 3 zeros. Now, let's say I want a 2D array, that is a matrix. And how many elements I want? I need 5 rows and 5 columns. That is, I want a 5 cross 5 matrix. Then what can I say? np dot zeros. Again, all the elements in that 5 cross 5 matrix should be zeros. Then I can call np dot zeros and then I can provide 5 comma 5. So I'm going to provide it as this 5 comma 5. And you see you get a 5 cross 5 matrix with all zeros. The same thing can be done with ones as well. So instead of zeros, I want to call ones. Let me do a control space and see how ones is written. So ones. And the same if I do here, I'll get a matrix with all ones. So if I have to generate a matrix with all zeros and all ones, I can use either zeros or ones. Okay. Now let's move on to the next one. Linspace. This is another function. So it basically returns evenly spaced numbers over a specified interval. Let's see. np.linspace. Let me do a control space and I get a suggestion linspace. And I will give 0, 10 and then I'll give a 3. So let's see what does it give. So basically in this interval 0 to 10, I want three numbers and those numbers should be evenly spaced. So since I want numbers between 0 and 10. 0 and 10 both are included. I want three numbers which are evenly spaced. So we have 0, then we have 5, and then we have 10. So these are evenly spaced numbers. The difference here is 5 and the difference here is also 5. If I want four numbers, so what should it be? So between 0 and 10, 0 and 10 included, I want four numbers, 0 and 10 included. So after 0, what we could have is, we want two numbers here, right? So what we can have? Can you tell me? Any suggestions? Let's see. So 0, 3.33. If you see between 0 and 3.333, there's a difference of 3.33. Then the next that we have is 6.667. The difference is also around 3.333. And again, the difference here would be of 3.333. So np.linspace is going to give us evenly spaced numbers over a specified interval, and both will be included. This is the starting of the interval. This is the ending of the interval. Okay. Let's say I want 50 numbers from 0 to 10. So I can write 0 to 10 is the interval, and I want 50 numbers. So I write like this, and I am going to get 50 numbers. So in this way, I've created a 1D array with 50 numbers which are evenly spaced and they are between 0 to 10. Okay. Now, let's move on to the next. Next is the I function. So, what does this I function do? It creates an identity matrix. Let's say I want a identity matrix, a 4 cross 4 matrix, which is an identity matrix. So basically all the diagonal elements would be 1s and rest everything is going to be 0. This is what an identity matrix is, right? Let me put this one here. So this is the identity matrix. If I want this identity matrix, that is basically I want the identity matrix of 4 cross 4, then what should I write? np dot I, and just say I want a matrix of 4 cross 4. Since it's the identity matrix, we don't have to write the number of rows and the number of columns. I can just write 4. I basically want the identity matrix which is of 4 cross 4 size, and this is what I get. So this is a matrix. That's why we have 2 square braces here. If I want an identity matrix of just size 1 cross 1, it would just be 1, right? So if I write 1 here, so I get here, I'll again get a matrix. It's not going to be a 1D array, it's going to be a 2D array. I'll get a matrix. Okay, so these are different ways of building arrays. There are a lot of built-in methods like arrange, zeros, ones, linspace, and these are all that we covered. Now let's discuss some array attributes and methods. I hope things are clear so far. Array attributes and methods. Okay, so let's discuss some useful attributes and methods on arrays, right? First, let's create an array. np dot array, and or maybe let's call np dot arrange and generate an array of 25 elements, that is 0, 1, 2 till 24. And let me store this in a variable called array or ARR, right? Or maybe X for simplicity. And let me print X now. So it's 0, 1 till 24. Now, if I want the maximum element, in this array, I can do X dot and call the max function. Max is written like this. So it's going to give me the maximum element in the array. If I want to change an element at any index, I can still do that. So 0 is stored at 0th index, 1 is stored at first index. This is 0 based indexing, right? Let's say we want to change this element. So what I can say is x 0, that is basically at the 0th element I want to change whatever is x0, I want to change it to, let's say, 6. And then if I see my x, 0 will be replaced by a 6. Again, let's say we want to change the 24th indexed element, that is the last element. Let me say it as 100. And now if I see my x, it's going to be 100 here instead of 24. And now if I see my max, it's going to be 100, right? Now, if I want to see at what index is the maximum element present, then I'm going to do argmax. So argmax is going to basically give me the index at which my maximum element is present. That is the 24th index. Let's say I bring the maximum element here. I can say x0 is 567. And then I see the max element, which is going to be 567. And if I see argmax, it's going to be the 0th index. Because 567 is present at the 0th index. Let me show it. 567 is present here. Okay, let's consider the same array and try to find the minimum element. So x dot min. Just like we have max, we have something called min also, which gives us the minimum element. What is the minimum element? It is 1. So the answer is going to be 1. Now, if I want the index at which the minimum element is present, then I can use x dot argmax. Argmin, sorry, not argmax, argmin. Basically giving us the index at which the minimum element is present. Obviously, it's going to be 1 because at index 1, the minimum element is present. Let me change the second element, the second indexed element, and write it as -1. And then see my x. The second index or the third position is changed to -1. And then let me do a x min, x dot min, calling the minimum method. So we are getting -1. And if we see the argmin, we are going to get second index. Here is the minimum element that is present. Okay. Now there's something called as shape also. Shape is an attribute that gives us the size of the array. It's not a method, it's an attribute. So we don't have parentheses with it. So if I have to call the shape, since it's an attribute, I just call x dot shape. I'm not going to have the parentheses. If I do this, I'm going to get an error. If I do like this, since it's a vector, it's a 1D array, the first element is going to tell us, it's going to tell us what are the total number of elements in the 1D array. The second is empty because we don't have rows and columns. We just have only one dimension. That is, this tells us that 25 elements are there in the array. Right? Now, we can also change the shape of the array. So right now it's a 1D array, right? It's a 1D array. I can change the shape by calling the reshape function. So if I call reshape, and now I want to change the shape. Right now it's a 1D array. 1D array, and the size is 25. Now I want to change it into a 2D array of I want to convert it into a 2D array, and the size that I want is 1 cross 25. So it's basically a 2D array, but it has inside it a 1D array of 25 elements. So I want to reshape it into the size 1 cross 25. So I'll write 1 comma 25. And now if I see my x, okay, first let's see this. You see, when we reshape it, we have got two square braces here, because what I have done is I've created a 2D array, and inside that 2D array I have just this 1D array with 25 elements. But when I call my x again, I will still get my same array back, that same vector back, which is the 1D array, because I'm not changing my x. I'm just reshaping my x here. I'm not changing my x. I'm just reshaping it and showing it here. If I write it as x equals to, then my x would be reshaped. Actually, and here I will be able to see that my x has also been reshaped. But here I'm not doing the I'm just calling reshape function on x. I'm not actually reshaping my x. I'm just calling the reshape function. So my x would remain as it is. If I do x is equals to, then actually x would also be reshaped. Okay, let's see. So x dot reshape is giving us 1 cross 25, 1 cross 25 sized matrix. One more thing, since here there are 25 elements, you can reshape it only in 1 cross 25. You cannot reshape it into 1 cross 30. If you try to do that, you're going to get an error, because cannot reshape array of size 25 into shape 1 cross 30. The number of elements here are 25 and here are also 25, but in 1 cross 30 the number of elements would become 30. The number of elements should be the same. Okay, does that make sense? Okay, now let me say x is equals to x dot reshape 1 comma 25. So what I'm doing is I am actually reshaping my x. So now your x has also changed. Now your x has become a 2D matrix, or a 2D array, or a matrix with the size 1 cross 25. So basically there is a 1D array inside this 2D array. Now let me call shape on this. So it would be 1 comma 25. So shape is an attribute and not a method. I can also change it into, now this is 1 cross 25, right? So basically there is one 1D array with 25 elements. I can change it to 25 cross 1 also, right? I can basically have 25 1D arrays with size 1. So if I do it, x dot reshape 25 comma 1. So basically 1 cross 25 matrix would be converted into 25 cross 1 matrix. That means there will be 25 1D arrays, and each of the 1D array will be of size 1. Okay. Let's move ahead. I hope reshape is clear. Now if I want to check the type of, say, x, what is this x basically? What is the data type? It's an array. It's a ND array. So we can get the type also by calling type function. Now let's move on to bracket indexing and selection. First, let me call my x. Now, if you want the element which is at the 0th index, what do? You say x, put the square braces, and inside that give the index. You want the element at the 0th index, so you give it as x0. So what will x0 give? It's giving you the 1D array. It's giving you the 1D array. So this is a 2D array, right? So x is a 2D array. And what is that 2D array? It's basically of 1 cross 25. So basically inside the 2D array, there is a 1D array of 25 elements. So I am finding out this at the 0th position. So this 1D array will be there at the 0th position. Okay. Now let me reshape it to 25. Now it will be converted into a 1D array, and let me say x is equals to x dot reshape. So now your X becomes a 1D array. And now if you want 567, that is the element at the 0th index, you get 567. If you want the element at the 3rd index, that is the 4th element, that is you get 3. I hope you understood why you are getting when you did x of 0 here. Why did you get the entire array? Because at the 0th index the entire array is present. So inside the 2D array there is a 1D array, and this would be at the 0th index. If there are multiple arrays, for example we have 1 comma 2 comma 3, then we have 4 comma 6 comma 7, and then we have 8 comma 9 comma minus 1, let's say. So if this is my array, if I call x of 0, if I want to find out what is x of 0, x of 0 is 1 comma 2 comma 3, this. If I want to have x of 2, then x of 2 is this, because this array is present actually at the 0th index, at the 1st index, and then at the 2nd index, because it's a 2D array. Okay. Now, let's say I want all the numbers from the 0th index till, let's say, the 3rd index. 0, 1, 2, 3. Okay. So, how do you call that? So, you can put a colon. This is how you actually select. You put a colon. You call from the 0th index till. You want till the 3rd index, right? 3rd index should be included. So that's why you're going to put the 4th index. So 0 index will be included and this index won't be included. So basically if you write x 0 to 4, you will have 0 included and 4 excluded. So here is the closed interval, here is the open interval. So that's why we have 0 to 4 when you want till the 3rd index. So if you see 567, 1 minus 1, 3. So what elements would be given? 0, 1, 2 and 3. 4th index won't be included. Okay, 4th index won't be included. I can just write like this also. So by default 0 will be the 1st index. So we still can get 567, 1 minus 1, 3. If let's say I want these 4, 5, 6, 7. So basically I want the element at which is this index 0, 1, 2, 3, 4. I want the element at 4th index, 5th index, 6th index and 7th index. So I want the 4th index, 5th index, 6th index and the 7th index. So 7 should be included, 8 should not be included. So I write it from 4 to 8. This is how I do it. Now, let's say I want these. So what are the indices? The indices are 22, 23 and 24. So from 22, I want it till 24. 24 should be included. So I'll write 25. Right? Instead of 25, which is the last index, I can also put a minus 1. So what is minus 1 actually? I'll explain you. So minus 1 means that the last element, this actually means the minus 1 index, this means the minus 2 index, this means the minus 3 index. Now when I'm writing it from 22 to minus 1, it means take the 22nd index and whatever indices are ahead of it till minus 1 index, that is till the 25th index, but the 25th index would not be included. So this is equivalent to writing (22 to 24). So if I write 22 to 24 here, what do I get? I get 22 and 23. Now when I write from 22 to minus 1 essentially means what? Minus 1 means the last index, but this is the last index, right? What is the last index? The last index is 24. The last index is 24. So minus 1 essentially means 24. So this index is minus 1, this index is minus 2. If I write 22 to minus 2, that means instead of minus 2, what am I writing? Instead of minus 2, I am writing this index, which is the, can you tell me which is this index? 23rd index. So this is also going to give the same result, and this is also going to give the same result. So instead of this, I can write minus 1. Instead of this index, I can write minus 2. Instead of this index, I can write minus 3, and so on. So if I am doing x of, let's say 18 to, I want from 18 to till the 23rd index, if I want this, then I could write 20, instead of 24, I could write it as minus 1 also. Why? It's fine because the 24th index is not included here also, and here also minus 1 means 24, but the 24th index won't be included. Okay, so instead of 24 index, I can put minus 1. Instead of 23rd index, I can put minus 2, and so on. If your array was, let's say, just having 1, 4, 8, 9, this was the array. So if you write x from the first index till the third index, that means 1 and 2 index will be included, that is 4 and 8. I can, instead of 3, I can write minus 1 also, which means that you include the first index, you include the second index, you include everything till the third index, but the third index is not included. So this will also be 4, 8. Okay. Now let's move on to broadcasting. Now Numpy arrays differ from a normal Python list because of their ability to broadcast. That is, we can change the array also, unlike the list. For example, this is our x. Now what I will do is, I will say from the 0th index till the 4th index, that is 0, 1, 2, 3, 4, all these, let's make them, all of them as 100. I can make this. And then if I see my x, all of them have been changed to 100. So this is basically the ability of changing the array, and this is called broadcasting. Now let me create a slice of this array. So this thing that is creating a subset of the array is called slicing. This is called slicing. So what we are doing is, basically from the entire array, we are just taking the subset of the array. So this is the subset of the big array x. So this is called slicing. So let me create a slice of the array, and let me just name it as slice of x. Okay. And here I will take 0, from 0th index I'll take till the 5th index. Okay. So 6th index won't be included. I'm going to take this, right? Now what do I do is, I say that all the elements in this slice of x, that is from 0th till the 6th position, since if I want to just take the entire array, I can just remove this also, and I can remove this also. So by default we'll have 0, and by default we'll have 6. So the starting by default would be 0, and by default the ending is going to be the last. So this is 0th index, 1 index, 2 index, 3 index, 4 index, and 5 index. And by default the last element, by default the last that will be is 6, not 5. So by default it's going to be 6. That is, it's going to be by default the last index plus 1. Okay. So let me say that I'm going to have all the elements as 99. Now if I see my slice of x, all the elements would be changed to 99. All the elements would be changed to 99. Now if I see my x, will my x change? Yes, my x will also change, because what we are doing is we are changing the x only. Even if we are changing the slice of x, we are changing the x only. The data is not copied, it's just the view of the original array. So if you are seeing the slice of x here, it's just the view of the original array, it's not something different. Slice of x is basically the slice of the array x only, and we are just viewing the subset. And if we are changing it, then we are actually changing our x also. So the change occurs in our original array also, because the data is not copied. The slice of x is not a copied version, or it's not the copied subset of x. It's actually the view of the original array. Now, let's see how do we index a 2D matrix, a 2D array. Let's create another array. I already explained you here. But let's create one. So y is equals to np dot array, and then in this we'll provide 1 2 3 as the first array, then 5 6 7 as the second array, and 8 9 10 as the third 1D array. So basically in this y we have 3 1D arrays. So what's going to be the size? It's going to be 3 cross 3. Let me see the shape. I'll get the size of it. Shape is, again, as I said, it's an attribute and not a method. So let's figure out what is y of 0 going to give us. At the 0th index in y, the 1D array is present. The 1D array is present, so the entire 1D array will be given. You see, 1 2 3. Now if let's say I just want the first element, so y0 is the array, is the 1D array. If I want the first element here, I need to just say I want the 0th index. So basically y0 comma 0, you can write it as y0 comma 0 also, is going to give you the element 1. So what is y0? It's basically this array, and now in this array, if you want the first element, you can just do y0 comma 0 or write y0 0. If you see x here, this is the 1D array, right? If I want the 0th index, I'm just doing x0, right? y0 is also a 1D array. y0 is also a 1D array. If I want the first element, I can just put a 0 in the square braces, or I can also write it as y0 comma 0. Okay. Now let's say if you want this element, it's basically stored at what position? If I want this element, then this array is at 0th index, this is at first, this is at second. So basically I want the element from the 1D array which is stored at the second index, and from that I want the first element, first indexed element. So I am going to write x2 1, or you can write x2 comma 1. So if I write y2 comma 1, I am going to get this element. I can also write it in this form. Now you can do slicing. You can do slicing in a 2D array also. What does slicing means? If we see, this is slicing. Basically taking a subset of the big array. A subsection of the big array. Let's say I want these two arrays, these two 1D arrays in my 2D array. I obviously have in Y, I have these 3 1D arrays, but I just want to show these. So I want a slice which just gives me these 2 1D arrays. So what do? Any suggestions? I basically want, let me show you Y again. I want the first and the second index. At the first index we have 1D array 5, 6, 7. At the second index we have the array 8, 9, 10. So I want from the first index, I want the first index, I want the second index. So basically I want 1, comma 2, both indices included. I'm writing 3 here because 3 will be excluded. So I get this, right? I get this. Now, let's say I just want 5 and 8. That is, I basically want 5 and 8. Out of this also, I just want the first column. So what can I do? Can I write like this? No, I cannot write like this because I have 5, 6, 7 and 8, 9, 10. Now in this array, at the 0th element, this is stored, and at the first element, this is stored. If I want 5, then what should I do? I have taken the 0th index 1D array. Now in that, I will have to put again a 0 to get my 5. Okay. I can also do the slicing in this way. Here I will do the slicing on the rows, and here I will do the slicing on the columns. So if I want 5, 6, 7, 8, 9, 10, that is the first and the second indexed records or rows, I'll do 1, 2, 3. This is basically the slicing on rows. And if I just want the first 2 columns, that is I want 5, 6, 8, 9, then can I do it like 0 to 2? That is 0 and 1 column will be included. Yes, so I can do it like this. I'll explain you all this here also. So you can assume this is the 0th row, this is the first row, this is the second row. This is 0th column, first column, and the second column. Okay. Now, if let's say this is y, I can say what rows I need and what columns I need. Here I can say the rows and here I can say the columns. Let's say I want the first 2 columns. So basically I want the 0th row till the first row. That is I want 0 and 1. So I should write 2 here because 2 won't be included. And if let's say I want these 2 columns, then I want the 0th column and the first column. So I'll write 0 to 2. If instead I want these 2, then what will I write? 1, 2, 3, because 1 and the first and the second column index, first index column and the second index column will be included. Make sense? Let's say I want 6, 7, 9, 10. So basically I want which rows? The first and the second, that is the first and the second indexed rows. So I'll write 1, 2, 3, and I want which columns? The first and the second columns, first indexed column and the second indexed column. So again 1, 2, 3. So I get 6, 7, 9, 10. If I want the bottom row, I can just write y2, I'll get the bottom row. I can also write, first I provide the row and I provide what columns I need. Since I need all the columns, so I can just put a colon saying that I need all the columns. So if I just put a colon, it means that I need everything. So I need all the indices in the column. So all the indices would be there. So either I can write it as this or I can write it as this. Okay. Now let's move on to one more important thing, which is selection. How do you select in an array? Let's see what our x is. Now, if I do x greater than 98, what will happen? Basically, all the elements at all the indices will be checked, and we are going to see are they greater than 98 or not. 99 is greater than 98, so I get a true. 99 is again greater than 98, so I get a true here. I get a true here. I get a true here. True here. So for 0th, 1st, 2nd, 3rd, 4th, 5th, 0th, 1st, 2nd, 3rd, 4th, 5th, I get trues. But for 6, I get a false because 6 is not greater than 98. So at all the indices, the elements will be checked and we are going to see if they are greater than 98. If they are greater than 98, we'll get a true at those indices, otherwise we are going to get a false. So I can store this in Z. So basically this Boolean array is stored in Z. Now what I will do is, I will take this X and I will, if I write a Z here, that means wherever there is a true, only those elements will be included in my X. If I see, only those elements, wherever there is a true, only those elements, only the elements at those indices will be selected. So basically, wherever there is a true, those will be selected. 99s and 100. I can do it directly also. If I want the elements, to be greater than, say, 99, I want the elements to be greater than 99. Let me see what are those elements. There's only one element, which is 100. So if I say I only want those elements which are greater than 99, then wherever there is a true here, that particular elements will only be added in this X of X greater than 99. Let me see my X again. So let's say I want only those elements which are greater than 10. So you see, wherever the element is greater than 10, we are going to get a true, otherwise we are going to get a false. And if I take X of this, only those elements wherever there is a true in X greater than 10, those will be included. So I get only those elements in X of X greater than 10 which have the value greater than 10. Okay, does that make sense? Let me explain it with another example. So if, let's say, I want the elements to be less than 8. So only 2 elements are less than 8. So only at these 2 positions I'm going to get a true. Now if I just want these 2 elements, then what I will do is, since this is going to be giving me booleans, so what I can do is I can take X of this. So basically, wherever there is a true for X less than 8, only those elements will be selected in my X. That is 6 and 7. Okay, X less than 8 is going to give me true only at these 2 places, and X of X less than 8 is only going to give me the corresponding 2 elements. Let's also discuss the Numpy operations. So let's see what our X is. Our X is this. Now, can I do X plus X? So if I do X plus X, what will happen? So 99 is the element at the 0th index. So basically all the elements at the corresponding, all the elements will be added to themselves. So if the array is, let's say, 1, 2, 3, if I add it with X itself, 1, 2, 3, so at the 0th index we have 1 and 1, so these 2 will be added and we'll get a 2 at the 0th index. At the first index we have 2 and 2, so 2 plus 2 will be 4, and at the first index we are going to get a 4, and then 3, 3 at the second index, so we get a 6. So similarly, 99 plus 99 is going to give me 198. 99 plus 99 is again going to give me 198. Then here 6 plus 6 is going to give me 12, and so on. And if I see my if I see my x won't change. If I do x is equals to x plus x, then obviously we can see the change. Similarly, I can do x into x also. So what would happen is 99 will be multiplied with 99, and 99 will be multiplied with 99. So all the elements at the corresponding indices, corresponding indexed elements are going to be multiplied. We can have another array also here, it's fine. So if I do one array is 1 comma 2 comma 3, and the next array is, let's say, 4 comma 6 comma 8, then basically 1 and 4 will be multiplied to give the 0th index element, 2 and 6 will be multiplied to give the first index element, and 3 and 8 will be multiplied to give the element which is at the second index. Okay. Also, let's say this is my x. I want to take the square root of all the elements. So I can do np dot square root of x. So this is going to give me an array, and all the elements will basically be the square root of their corresponding elements. So 9.94987 is going to be the square root of 99. Same, this is going to be the square root of this. This is going to be the square root of this, and so on. I can also do exponential. So if I write exp of x, then what will happen is basically the first element would become e to the power 99, the second element would be e to the power 99, the third element would also be e to the power 99, this element would be e to the power 23. So if, let's say, the array is 1 comma 2 comma 3, and if I do np dot exp of this, then basically the array that I'm going to get is e to the power 1, e to the power 2, and e to the power 3. I hope you know what e is. E is the Euler's number. Okay. So this is pretty much about the Numpy. So we covered a lot today. We actually did everything in Numpys. What is Numpys? First of all, it's basically a standard package in Python which is basically used for array processing. And there are two Numpy arrays. One is the 1D arrays, which are called vectors, and then we have the 2D arrays, which are called matrices, right? And we have built-in methods in which we can create arrays by range, zeros, ones, I, linspace, etc. And then we discuss the attributes and methods of array. For example, max, min, argmax, argmin. We also discuss shape, which is an attribute and not a method. We discussed reshape also, which is a method. Then we also understood the indexing, the selection, and the slicing on the 1D as well as the 2D arrays. We understood broadcasting as well. Then we moved ahead to basically selecting the arrays based on some condition. And then we did Numpy operations. So that's it for Numpys. In the next class, we are going to discuss another important package of Python. Thank you.